Alrighty, so we talked about forest fires. What happens when all the trees burn? Is the matter destroyed? Are the tree molecules, tree atoms destroyed? No. And the answer is no, right? All the carbon is converted to gases, mainly carbon dioxide. The carbon in the trees is converted to the C, carbon in carbon dioxide, gas, right? And it goes into the Earth's atmosphere where it warms the Earth's atmosphere due to climate change, or climate change theory, and eventually killing us all. Yeah. So, what is a scientific law, like the conservation of matter law? Well, a scientific law is a general statement that sums up the conclusions of many experiments, and it states that a pattern has been observed. In other words, what goes up must come down. That's an example, right? Laws do have certain restrictions, like, for example, when I did the helium balloon thing, right? Logan, I'll put this up a little bit later so you can, okay, just so we can get moving on here. Okay, so what is the law of conservation of mass? Well, it says that in a chemical reaction, the total mass of the reactants is equal to the mass of the products, right? The before and the after mass are the same.
Okay. I'm just looking.
Making sure?
Yeah.
Atoms are not changed or destroyed, only the arrangement is changed. And I like to refer to that as the Brad Pitt, Jennifer Aniston kind of analogy, right? Just trading in for a new girl. You can even call it the Donald Trump, you know, with the 3 different wives. Am I being recorded here? Uh-oh, I'm going to be investigated. I'm being recorded. Better not post that. Thanks for your support. I'll be sure to ask you for help when I have my one phone call. I'll be calling you guys. Yeah. You'll be there for me. Thanks, Sam.
Show them the balloon shirt.
Oh, yeah. Ooh, he's a wizard.
What is this one?
All right, so I showed you the word equation for burning natural gas, which is methane. Methane is CH4, combines with oxygen. Where does that oxygen come from? From the atmosphere, the air, and it creates water and carbon dioxide. The left-hand side are known as the reactants, and the right-hand side are known as the products. And then we sort of did some atom counting here, and we decided that we don't have enough H's. Over here, how many H's we got? 4 H's, but here we only got 2. And do you remember how I solved that? I had to put a 2 in front of that, right? Now I have 2 H2Os, which is a total of 4, and you'll also notice that I now have 2 O's, and those 2 O's give me, oh, how many O's have I got here? 2 O's, here I got 2 O's, how many O's is that altogether? 4, but how many O's have I got over here? Only got 2, so you know what? To make that balanced, I'm going to have to do that. That's sort of something down the road. We're going to do that real soon. Don't worry too much about that if you don't get that today. But regardless of that, the mass of the atoms on each side must remain the same, and that's because the number of atoms remains the same. Okay, here's where we left off, right? I think? Am I right? Okay, so all right, so an environmental view. The law of conservation of mass has implications far beyond the laboratory. Think about engines that use fuels as a source of energy. In other words, cars. When cars burn gasoline, energy is released during the chemical reaction of combustion. However, since mass is conserved, all of the mass of the fuel is still present in some form after the combustion occurs. So what that means is this, right? Each kilogram of gas mixed with oxygen produces about 3 to 4 kilograms of water vapor and other gases. You should maybe jot this down on your little note sheet there. Each kilogram of gas mixed with oxygen produces about 3 to 4 kilograms of water vapor and other gases. And we showed the other day there, we showed that the mass of the gas in the balloon, there is a mass of the gas, right? Charles, you should put your phone away. Because you're going at 10:45, so don't worry about it, right? One gallon of gas weighs about 6 pounds. I looked it up. Right? That's just like, think of like a 4 liter of milk. Right? That's about 6 pounds. Where does that 6 pounds of stuff go? Into the air. 6 pounds of gas, more or less, right? Combined with the oxygen, you actually get more. It's hard to believe, right, that that gas would be weighing 6 pounds, right? 6 pounds is a fair bit. Think about a jug of milk. That's how much you're putting into the atmosphere. Large vehicles have up to 80 liters of gas in a tank, or about 18 gallons. About 108 pounds of gas is released into the air for every tank that you burn. Right? So you drive to Brandon and back, or Winnipeg and back, maybe a tank and a half. Brandon and back would you burn a tank of gas to Brandon and back? Maybe 3/4, right? So maybe 75 pounds of carbon dioxide and other gases is released into the atmosphere. That seems like quite a bit, right? That's just one car going to Brandon and back. Okay. Now, what do you guys have on your sheet? You just have the example? Okay. Okay. So again, let's go back to our word equation here. Methane plus oxygen gives us water and carbon dioxide. So if you have 60 grams of methane, perhaps in a balloon, that would explode, by the way. Did you guys do when you came for the grade 9 orientation, did you do the gas bubbles in your hands, right? Did you do that? Okay, so do you know what gas is in the bubbles? Methane. That's what's coming out of the little gas jets there in the science room. So 60 grams of methane reacts with 120 grams of oxygen to produce how much water and carbon dioxide? Well, the law of conservation of mass says that the mass before has to equal the mass after. So what do? 60 plus 120 would be 180 grams. You get 180 grams total of water and carbon dioxide. All right, just add them together. 60 plus 120, you get 180 grams of water and carbon dioxide. So now, if there's 100 grams of water, how much carbon dioxide is there? How would we do that? This 180 is water plus carbon dioxide. So if there's 100 grams of water, how much carbon dioxide is there? How would you do that? 180 minus 100, of course, 80 grams. I did it so you don't need to calculate. Does that make sense, Ruben? Yeah? All good? Easy? So easy. It's just the idea, bing, light went off, right? Use that algebra off. Kids get it, I'll just turn the light on. Okay, let's try another one. 25 grams of carbon monoxide reacts with 20 grams of oxygen. How much CO2 does it produce? It only produces carbon dioxide. You guys have a question, I'm sure, right? Okay. So 25 grams of carbon monoxide reacts with 20 grams of oxygen. How much CO2 does it produce? What do, Tiffany? Simply add them together, right? I got 25 grams of carbon monoxide reacting with 20 grams of oxygen for a total of 45 grams. The total before has to be the same as the total after. Law of conservation of mass. Easy stuff, right?
Yeah.
"45 grams of aluminum reacts with bromine gas. It produced 65 grams of aluminum bromide. How much bromine gas?" It says it was produced. Reacts. That doesn't make sense, right? It should. What's that? Yeah, but it shouldn't. The word "produced" is not right, is it? It should say what? No, it's not spelled wrong. Is the bromine gas produced? No, it's aluminum plus the bromine gas, the Br2, and it produces aluminum bromide. I'm not sure what the formula for that is, but how much bromine gas was not produced was Used. Stroke out, produced, and put in used, right? How much bromine gas was used? So this is right. You're going to have to subtract. I got 45 there. And I got 65. Is this not just the same as like algebra, math? Right? I'm solving for x there, right? How do I solve that for x? What do I do with that 45? Take that aside, right? X is going to be 65 minus 45. We're really doing math. 20 grams, right? 100% on this test, right? Yeah, it's pretty easy. Now, did you know? Okay, so, well, let me just do this here. 40 grams of calcium reacts with 36 grams of H2O to produce 2 grams of H2. How many grams of CaOH2 were produced? So let's just write it out. So I got my Ca reacting with what? H2O. And it's producing what? H2 and also CaOH2. Right? So let's just write it out like that. How much calcium did we use? 40 grams. How much water did we use? 36. And that produces how much H2? 2 plus x, some unknown. So you're solving for x. It's impossible to solve, those numbers are too big, is that what you said? You see this look on my face? Does that help, Tiffany? So now what? 40 plus 36 is going to give you 76 equals 2 plus x, right? So what is x equal to? $74, right? X is 74? Yeah, does that help, ladies? Okay. You're supposed to write the word equation. So here, you're going to have to go back and look at your naming, right? Maybe should I just do this whole question with you? Okay, write the word equation. So it's Ca. Well, what is the word for Ca? Calcium plus H2O, water. H2, what is H2? Do you know? Yeah, I don't think I went through those with you. H2 is hydrogen gas. H2 is hydrogen gas. And what's CaOH2? How do you name that? CaOH2. Now, actually, this is a good review because when we did the naming stuff, I had people that were confused about, do you use the prefixes or do I not use the prefixes? So what's the rule? When do you use the prefixes? When it's two nonmetals, when it's covalent bond, right? Is this two nonmetals? CaOH2, no, this is one of those polyatomic ones, right? Remember that chart with the different things? Right? OH is a hydroxide. So CaOH2, no prefix is going to be hydrogen OH2. Oh, not hydrogen. What am I doing? Ca is calcium. OH2 is hydroxide. That's your word equation. Calcium plus water gives you hydrogen gas plus calcium hydroxide. Now, I think number 2 is the same thing, except now you're looking for the H2O. Why don't you guys just try this on your own, and then we'll do it right away. Let's do this assignment this way. So what do you got here? You got 25 grams of calcium reacting with an unknown amount of H2O. So it's going to be 25 plus some unknown X produces 1 gram of H2. So 1 plus 34 grams of CaOH2. Did you do that? And it just disappeared. That's wonderful. So now I got 25 plus X is going to be equal to 35. So X should be equal to 10. Right? Write the word equation for the reaction. So you got calcium plus unknown amount of H2O. So that's calcium plus water to produce 1 gram of H2. Well, this is the same one, isn't it? Well, that's easy. You think you can do the rest of the sheet now? Maybe? Give it a try. Okay? Acetic acid, which is 5% of vinegar. Vinegar is 5% acetic acid and 95% water, is CH3COOH. That's the formula for it. Okay, Jesse, you watching? It reacts with Alka-Seltzer. What are the reactants in this equation? Acetic acid, vinegar, is CH3COOH. It reacts with Alka-Seltzer. So what are the two things on the left-hand side? Vinegar plus what? It reacts with Alka-Seltzer. What's it reacting with? Alka-Seltzer. You just have to write down what are the two things that are reacting. That's all you got to do. It reacts with Alka-Seltzer to produce. That's your arrow. To produce water. Water. Carbon dioxide. Carbon dioxide. And sodium acetate. All you have to do is write down the words in the equation. That's what it's asking for. That's what the word equation means. Write the word equation. Huh? Yes, I know. My writing's not very good there. And I'm on a Word document here, so it's a little bit challenging to write. Okay? If 3 grams of Alka-Seltzer reacts with 50 grams of acetic acid, how much sodium acetate is produced if 25 grams of water and 2 grams of carbon dioxide is produced? So what do you have to do with those numbers? You got to put them all in here, right? And now I've really got myself a mess, don't I? Okay, so we got 3 grams of Alka-Seltzer reacting with 50 grams of acetic acid. So it's going to be 50 plus 3 on the left produces 25 grams of water, 2 grams of carbon dioxide. We're trying to find the sodium acetate, which is this one. You asked me, Alyssa, about the sodium acetate? Yeah, this is the sodium acetate here, right? So this is our X. Plus, the next one was the water. How much water we got? 25. How much carbon dioxide we got? Plus 2. Can you solve that?
Yes.
I'm hoping you don't need a calculator for 50 plus 3. And it just disappeared. Where'd it go? So you're going to have how much on the left-hand side? 53, right? 50 plus 3, 53? Please tell me you don't need a calculator for that.
I don't know.
25, then you got the unknown, that's your X. And you got 25 plus 2, which is 27. Please tell me you don't need a calculator for 25 plus 2. Now what? 27's got to go to the other side, right? Now, here's where I'm okay with you using a calculator. Right? What's 53 minus 27? 26 what? Grams of sodium acetate. If I had to make this assignment better for students, what would I do? Say again a little louder, AJ. Say again a little louder.
Don't put in that.
Don't put in math.
That'd be a little bit. That is hard.
Hey? Yeah, it's good. Yeah. Okay. Well, seeing as I'm doing the sheet with you, let's do number 5 together, shall we? And then we'll call it a day. A silver bracelet weighs 250 grams. As time goes on, a black tarnish appears on the bracelet, and the weight increases to 252.5 grams.
Oh my gosh.
It weighs more. Tiffany, are you listening? It weighs more. Explain where this extra weight comes from. Where did the extra? I started with 250. Afterwards, I got 252.5. How much did I gain? 2.5 grams is gained. Where does it come from? Poof, thin air? Well, actually, yes. Poof, thin air. Where is it coming from?
Air.
What's happening? The silver is the what? The what? Where is it? The air is reacting with the silver and producing this tarnish, this black brine, and the black brine weighs 2.5 grams. Where does it come? Where are the atoms coming from? The air. You know what that reaction is? It says bonus, do some research. Let's find out right now. Let's find out right now. Silver tarnish reaction. The tarnish is actually a result of a chemical reaction between the silver and sulfur-containing substances in the air. The silver is actually combining with sulfur and forming silver sulfide. Silver sulfide is black. When a thin coating of silver sulfide forms on the surface of silver, it darkens the silver. Yeah.
Silver plate here that's, as you can see, well tarnished.
So that's what the tarnish looks like.
Tarnished with magnesium. Oh, I can really smell the hydrogen sulfide gas. Wow.
This is pretty exciting.
And I'm dipping the magnesium into this beaker over here. That beaker contains warm water, so I can easily put my hand in it without getting hurt. It's got warm water, it's got a little bit of salt, and it's got some baking soda in it. Well, I've continued cleaning for about 10 or 15 minutes, and there's your finished product. You can contrast that with the magnesium. Look how nasty that stuff looks. All the sulfide ions were taken off of the silver and chemically deposited on the magnesium, and now the magnesium is quite gray.
What did he say was in the water? Yeah, which is salt, NaCl, baking soda, HCO3, and so there's a reaction with the magnesium, and it's doing what? It's taking that tarnish right off, leaving the silver all by itself. Basic chemistry. Can you easily put your hand in salt and baking soda? Yes. Yeah, no. I think we might have to do some more law of conservation and math stuff. I'm a little worried. Because when we get to balancing equations, we're going to have to do some math. Well, you're going to keep saying I'm no good at math, and I'm going to keep making you do it, AJ, so I'm going to win. You're not getting out of it by just saying I can't do it. You're going to do it. but I don't have anything ready for today, so we will leave it at that. Hopefully I see you tomorrow.
Yeah, that hope will.